Assignment 5, Part 4. Okay, so even and odd functions, which we started to look at. Okay, so for an even function, the x's change. So we already looked at this. So f of negative x equals f of x, and the graph is symmetric with respect to the y-axis. So I can draw a dotted line on the y-axis. If I fold this paper on the dotted line, this will fall on this, or this will fall on this, which way you fold it. Now, remember, for odd functions, it's symmetric with respect to the origin. So that's where your x's and y's are both opposite. It's through the origin. So if you looked at this point, it would match up with this point because it goes through the origin. Okay. Or I look at it as you're making two folds. Okay, and it doesn't matter the order. So here I fold over the x-axis and then the y-axis. And if you do it in the reverse order, it doesn't make a difference. So for example, the second picture here, if I fold this bottom piece, if I start at the origin, if I fold this bottom piece over the origin, I get this. I'm sorry, over the x. Now, if I fold this over the y, I'm on top of here. So if the two folds work, it's symmetric to the origin. You could have also folded it over the x and you would get this. And if you fold it up, you're still on top. So it's still two folds. It doesn't matter which way you fold it. It doesn't matter the order here. All right. So let's take a look at a couple of problems. Or actually, one more note. Okay, so some functions are neither even nor odd. The only function that's both even or odd is the zero function, f of x equals 0. In all the cases of a function is even, it cannot be odd. This is the one I like. Okay? If all your powers, okay, so if all your terms are even, the function's even. If all your terms are odd, the function is odd. Right. So let's just look at a quick example before we look at the real examples. Let's say you have y equals 5x cubed plus 4x. So what we're doing is we're looking at the powers. We have a 3 and this one, which we don't write, but we know this is a power of 1. Okay, so 3 and 1. Those are both odd powers. Okay, so this is an odd function. Okay, so number 2, let's look at a couple even powers. 4x to the 6th minus 5x squared. Okay, 6 and 2, those are, excuse me, those are even powers, so that's an even function. And also, you could also use the stuff we learned earlier, earlier topics in this assignment. This here for odd, you get negative f of negative x equals f of x. Sorry, you just get f of negative x No, actually, I don't want to go with that. Never mind. Nope, we're not going. Just stick with that. The other thing to watch out for, sorry, got sidetracked, is a constant is considered even. Okay, so a constant is even. So this should be considered even power. And actually, let's try to not make bad conclusions. Okay, so this power here, it's really, this has an x power of 0. This is still an even function. So a constant, no matter if it's even, odd, positive, negative, a constant is considered part of an even function. Okay, so so the constant isn't even, but the constant is considered part of an even function. All right, let's take a look at some examples. So we have 4 examples here. Let's go with A, B, C, D. Okay. All right. This one, if I even, would be folding it over the X. If I fold this down, if I fold over the X here and I fold this down, doesn't work. Okay. So that doesn't work. Odd. So if I fold, let's say if I fold this piece over, I get something like this. And now if I fold it over the X, this maps up to this maps down to this is an odd. Or you can look here and here, it goes through the origin, they match up. Here and here, it goes through the origin, it matches up. There's a lot of different ways of looking at that one. That's probably the more difficult one. Okay, is this even? Can we flip it over the X? No. So not even. Let's take this one. Let's take this point here and go through the origin. Is it down there? So if I take this piece, if I flip it down and then across, nope, doesn't match up. Not odd, so it's neither. C and D are a lot easier. So C, we have an even power and an odd power. So we have an even power, odd power. If it's mixed, we're getting neither. It can't be both. You can only pick one here, unlike the other problems in earlier in the assignment. Okay, part D, odd function. Okay, there's only one power. It's odd. There we go, odd function. So hopefully these are easier. Let's get another problem. Let's go with A, B, C, D again. Okay, we just looked at one just like this. I just picked them from Alex, sorry. If I flip this over the X, not even. If I flip this piece, take this piece, if I flip it down and across just like before, not odd, neither. Okay, if I flip this over the X, I get this, not even. If I flip this, let's take this piece. If I flip it down, I get this. If I flip it across, I get this. It doesn't match, not odd, neither. Now here's the easier ones. Odd power, odd. This one, even power, even. Okay? So I stumbled through a little bit earlier, but this should hopefully clear it up. Okay, next topic. Sum and difference of product of two functions. So either subtracting, adding, or multiplying. So the first problem, it'll go A, B, C. So for part A, it's going to be t minus x and simplify as much as possible. So t is 4x minus squared. There's our t. Okay, there's our t right there. There's our s. So go with, so your red is 4x minus squared minus, and your blue function is x plus 5. Always put it in with parentheses. So all you have to do here is distribute 4x squared minus x minus 5. I distributed the negative 1. There's no like terms here to combine, so you're all done. So that's part A. Part B, I'm not going to use the different colors again. It's t plus s, 4x squared plus x plus 5. Technically, with a plus, you don't need parentheses. I just like using them because when you distribute the positive 1, it stays the same. So 4x squared plus 1 times x is plus x, plus 1 times plus 5 is plus 5. There are no like terms, so that's our answer. And now part C. Part C, they give you a number. So we're going to take t of 3 times s of 3. All right, so we're going to start with the red. We're going to go t of 3 times s of 3. So t of 3 would be 4 times 3 squared. So that's one piece. And s of 3 would be 3 plus 5. All right. So 3 squared is 9. 9 times 4 is 36. So we get 36 times 8. All right. And we can just use a calculator for that. We can use a calculator for all this if you want. 36 times 8, we get 288. So in these problems, when you have an x, you're going to get an expression. When you have a number here, you're going to evaluate. That's why it says write the expression. I'm pretty sure Alex makes you simplify. Evaluate, we're finding a number because there's a number here. We're plugging in 3 to both of those and multiplying it together. I kind of like thinking of it as brackets because we have two different pieces here. So this was 36, this was 8, multiply them together. Okay, so here we have another A, B, and C. Okay, so I want to point out A. A is H times G. So whenever you're multiplying, you put expressions in parentheses. That's always the safest way to do it. So for this one, to simplify this one here, we have to FOIL or double distribute. So I go x times 3x, 3x squared, x times negative 1 minus x, 6 times 3x, 18x, and 6 times negative 1 minus 6. And then, like always, combine like terms. Negative 1 plus 18 is plus 17x minus 6. Okay. B, h minus g, x plus 6 minus, we're going to have to distribute here, 3x minus 1. And if you can do some of this stuff in your head, I'm okay with that. So distribute the negative 1, x plus 6, negative 1 times 3x minus 3x, negative 1 times negative 1 plus 1. All right, combine like terms. X minus 3x, negative 2x. 6 plus 1 is 7. Doesn't really matter what order you write that in. I just always, write out my x's first. And the last one, h of 3 plus g of 3. Okay, so you're putting 3 into both of those. So h of 3 is 9. Okay, because 3 plus 6 is 9. And g of 3 is 3 times 3 is 9 minus 1 is 8. So 9 plus 8, you get 17. Okay. And here's one more for you to try if you'd like. There we go. That should help a little bit. Okay, so here we go. We'll go A, B, C again. Sorry, this is our third problem. I wasn't numbering before. All right, A. So if you want to try it, pause it. I'm going to continue on. So A, we're going to multiply G, which is x cubed times 5x squared. And we have to know our basics. 1 times 5 is 5. And when we multiply bases that are the same, we do what to the exponents? Okay, the answer is add. So 3 plus 2 is 5. 5x to the fifth. B, we're going to take G minus H. Okay. We don't really need parentheses there because it's a monomial, but I like doing the same thing every time. So x cubed negative 1 times 5x squared is a minus 5x squared. There are no like terms there. You're all done. There's no reason to factor because you're just trying to simplify. And C, G of 2 plus H of 2. So I'm going to plug 2 into G. 2 times 2 times 2 is 8. Plus, I'm going to plug 2 into H. 2 squared is 4. 4 times 5 is 20. We get 28. Okay, let's move on. All right, so same kind of concept, but now we're looking at division. Quotient is a fancy word for division. So A, find G over H of negative 2. So what we're going to do for A is we're going to do G of negative 2 over H of negative 2. Okay. You can use your calculator here, but you will get a fraction. They don't want a decimal answer. So G of negative 2, negative 2 squared is 4. 4 times 2 is 8. Negative 7 plus 8 is 1. Okay, so in your calculator, just put negative 7 plus 2. Remember, very important to put parentheses around that negative 2 squared. And that should give you 1. Okay, make sure you have parentheses or the calculator will lie to you. So H of negative 2, plug in negative 2 here. 7 plus 16, that's 23. So our final answer, 1 over 23. Okay, find all values that are not in the domain of G over H. So I'm going to write G over H. Okay, this is part B. So excluded values not in the domain, that's when your denominator or bottom equals 0. And of course, we have to solve once we set that equal to 0. So we're going to do, take the bottom. We don't care about the top. Because remember, it's illegal to divide by 0. So we subtract 7 from both sides. And then we divide by negative 8. So a negative over a negative, I'm sure Alex is going to want the positive answer. X equals 7/8. So if you plug 7/8 into here, you get some number on top, whatever it is. It's probably a decimal or a fraction. But you get 0 on the bottom. You cannot divide by 0. So that's the key here. Denominator equals 0 and solve. All we care about is the bottom. Denominator is the bottom. Okay. Here's one more problem for you to try. If you want to pause it, go ahead. So A, G of negative 5. I don't know why I did an equal sign. G of negative 5 over H of negative 5. G of -5 plus 7 is 2. H of -5, that is -3 times -1, which is +3, so 2/3. And now G over H. All we care about is the H, so you could really skip writing this out. Okay, so this was nice of them. This is already factored, so we're going to set the bottom equal to 0, and it's called the zero product property, something we've been using a long time in math. You've seen it in many courses. We set both pieces equal to 0 and solve, so we get -2. Sorry, I was a little ugly there. And -4. All right. And that concludes this video.